In this video, we will be talking about the definition and terminologies that altogether associate themselves with functions. This particular lesson is actually falls under the subject of general math. This is a subject that you will have in senior high school, particularly here in the Philippines, grades 11 and 12. Uh, this subject is also seen in specific strands such as STEM and ABM. I'm not sure if general math is also a subject in other strands such as IBDP or perhaps GAS or general academic strand. It, STEM, by the way, stands for science, technology, engineering, and mathematics. ABM stands for accounting, business management, while IBDP is basically the what we call the International Baccalaureate Program or Diploma Program, if I'm not mistaken. So yeah, let's head to the actual topic of this video. So first thing we need to know is that variables dictate a result. So how do we determine if a given graph is a function or not? There's only one way to determine if a function is actually to determine if a relation is a function or not. By the way, the word relation is a more generalized term of what we call functions, but not all relations are functions. That's something that we need to know. So, what's our solution? This is called the vertical line test. So basically, for this test, we check the number of intersections with a vertical line. So here in our usual Cartesian plane, anywhere in the x-axis actually, we could place a vertical line. And what do we do with the vertical line? So given a scenario wherein this is your function as a graph, so you basically have a parabola written that way or drawn that way. And when you place the vertical line, you can see that there is one intersection. This intersection is where your vertical line literally intersects with your parabola. So with one intersection, you can already determine that the graph or the function interpreted as a graph is a function. So here in the right scenario, the scenario here at the right side um, of the screen, given a parabola written this way, uh, and given you've already drawn the vertical line, you can already see that there are two intersections. So what does that mean if there are two intersections or perhaps more? But basically, normally with two intersections, you could already know that this graph is a non-function. So, what similarity does in a function and a non-function share? Basically, they're both relations. They're both relations. Now, something that we have to know is that a circle, for instance, will always be a non-function. Hence, circle is not equal to function. Why? If you put a vertical line in the graph, you can already see that there are two intersections. So obviously, a circle isn't a function. It's rather a relation. So, for independent variable or set A, we should acknowledge that in every set A that we can see in our exam, that already refers to domain. Of course, what I'm saying right now is in the context of the lesson of functions. As for set B, that will always refer to the range. The domain is the independent variable, while the range is the dependent variable. So I could hope you could find a way to familiarize yourself, or better, both memorize and understand these concepts, these ones. It will come in handy when it comes to the problem solving. So right now we are given 4 questions to solve. So basically, what we're supposed to find here is to determine whether or not uh, the given is a function or a non-function. So for letter A, uh, as you can see here, A matches to P, B matches to Q, C also matches to the same letter Q, D matches to R. So in this sense, we call this a function. Why? Let me give you references here. So domain element cannot have no match in range, otherwise it's a non-function. A range element can have no match in the domain, but it's still a function overall. So here you can have one domain intersecting with more with a range. So in easier terms, one element in the range can be, or in other words, can have an affair with multiple elements in the domain. So I know it's not exactly that appropriate to say um, to define what a function is in that specific situation, but yeah, I hope it does make you understand it better. And here for letter B, as you can see, for letter A, element A from set A, which is the domain, it has an affair with um, multiple elements in the range. So in that sense, we could already say that this is a non-function. Only it's we call a function, it's considered a function if um, it's just either the range has multiple elements, is associated with multiple elements in the domain, or that um, one domain has its own unique element match in the range. So for letter C, as you can see here, one element in the domain has no match with the range. Rationally, we could just put a match like this, but then that's not the actual scenario. So in this sense, we cannot also, I mean, it is a function if every element in the domain has a match. But here, there is no match for one of the elements in the domain or in set A. Therefore, this is not a function. So I guess that makes 3 definitions on what makes a function. Right, for letter D, as you can see here, all elements in the domain have their corresponding matches. But for the range, there is one element that doesn't have a match from the domain. So in that sense, this is still considered a function. I hope you get the pattern. All right. Every element in the domain should have a match in the range. You can have more range elements match with one domain, but you cannot have more domain elements match with one range. So those are basically conclusions based on observations. So yeah, in the context of a function, x would always be referred to as the domain. It doesn't repeat. It doesn't have an affair with multiple elements in the range. It only has one match, therefore. And for letter Y, that's usually the range. It's associated completely with the range. That's better. It can repeat, or in other words, the range, a range element can have multiple affairs with domain elements, but then, so yeah, it can only have one or more matches. Just forget that I said the word only. It could have more than one matches. Anyways, as for the set of ordered pairs, for letter A, um, so before we are given these kinds of practice problems. So this time, we're to determine if a set of ordered pairs are a function or not. So for letter A, how do we know? Um, the domain is no repeating, while range can repeat. So for letter A, you can see that the domain, there are no repeated values, therefore this is a function. Alright, for letter B, as you can see here, range elements repeated, so it's still a function. Why? You can see here, 9, 4, and -1. Those are the elements of the domain. They're not the same, so they don't repeat. B is a function. For letter C, the set of ordered pairs, as you can see here, -2, the domain was repeated twice. So this is not a function. Alright. I hope you're getting it. So far, so good. Concept. These concepts are pretty easy, especially if you've already practiced, you got used to it. So yeah. Here, this is basically the same as determining whether the set of ordered pairs are a function or a non-function. But what's different is that they are written, the elements of domain and range are written in tabular form. So, oh, I'm supposed to remove this answer, but anyways, I'll consider that a bonus. For letter B, since the domain is repeated, it's obviously a non-function. And here, for letter A, no elements in the domain or set A, or in other words, X, the X values, none of them repeat or imitate each other. So they're not the same numbers. While at set B, or the range, you can see that there are two numbers that are the same, two elements. So it's still fine as a function. So yeah, that's everything. What is a function? A function is a rule by which one element in one set is made to correspond to exactly one element in another set. So here, let's proceed to the warm-up practices. We should determine whether the mappings shown represent functions or non-functions. If it is a non-function, explain why the definition of a function is not satisfied. So yeah, let's proceed there. So number 1, set A, this is set A, and this is set B. So Cesar Virata matches Philippines, Malcolm Fraser matches Australia, Lee Kuan Yew matches Singapore, Li Keqiang refers to China, and Bob Hawke refers to Australia. So one element in the domain, in the range, has an affair with two elements in the domain. So obviously, with that detail, you can see that elements in the domain have their own corresponding matches in the range. So this is a function. So for the reason, set B, which is country, in other words, as you can see here, set B refers to country, is an independent variable whose domain elements do not pair with two or more elements from set A. Note that this is the um, independent variable. Ranges. So yeah, basically from set A, they have their own matches from range, and basically they don't commit such thing as polygamy. This might be controversial, adding this term to this lesson, but then, yeah, the concept is the same in a certain sense. So, yeah, this is the final answer. All right, so for number 2, we have book and author for set A and set B, respectively. We have Hawaii to Missioner, Roots to Haley, Shogun to Clavel, 20,000 Links Under the Sea, Verne, Where the Red Fern Grows to Rawls. So, as you can see here that all domains match with their own range elements altogether. So, number 2 is a perfect definition of what's stated here. One element to one domain, all elements match each other, in a sense that they're committing the opposite of polygamy, which is more, I don't know the word, but then yeah, you marry one person, you marry a husband or a wife, you don't commit polygamy. Anyways, for function y, set B, or the authors is an independent variable whose domain elements do not pair with two or more elements from set A, or in other words, the independent variable ranges. That might not make sense, I apologize, but then I hope you do get the context. I made this reviewer a few weeks ago, and I'm starting to realize that it's becoming more inefficient as I haven't recorded it for quite a long time after it was created. So, yeah. But you do get the context. No element in the domain is associated with two or more elements in the range. So it's a function. Now, for number 3, we have basketball star. That's our set A. And reported height would be our set B. So MJ is 6'6". The mailman is 6'9". Doctor is 6'7". The Iceman is also 6'7". And the Shark is 7'1", 7'2". So as you can see here, I suppose that this refers to the name of a famous basketball player named Shaq O'Neal. He is damn tall. So yeah, right now he's an element in the domain, and he is associated with two elements in the range, two in specific. So this is a non-function. Right, so I think you know the reason. Shock, or one of the elements in set A, or the independent variable, has exactly two matches in the range. So yeah, this is the reason why this particular table is a non-function. Right, let's move to number 4. For country region, this is set A, and language refers to set B. Right, Canada. Um, right now, I think it's already safe to say that um, this is a non-function. But yeah, let's just go ahead. Canada's English, French. China is Mandarin. Argentina is Portuguese. uh, Mexico is Spanish. Belgium is French. So, um, an element in the range has two affairs, to be exact, from the domain, while um, one element in the domain has an affair with two elements in the range. So it's obviously a non-function, even though um, this detail makes usually indicates that um, two sets are considered a function. But then because of Canada being affiliated with French and English, this table altogether is a non-function. So yeah, I think I've already said the reason. Right. Let's just say that never happened. Humorously enough. Right. So for letter B, determine whether the set of ordered pairs represent a function or a non-function. Right. For number 1, we have 0, 0, 1, 1, 2, 2. So it's a function. Why? Um, the x values which represent elements of the domain, they're not the same as each other. So domain, in other words the x value, is not repeated. Okay. For number 2, 1, 2, 2, 2, 3, 2. So based on the domain elements, this is still a function. So I think you know the reason already. I wouldn't have to write it anymore. The same reason as number 1. For number 3, as you can see here, domain elements are repeated thrice actually. So this is a non-function. Obviously a non-function. There you go. Oops. Okay, let's move on to number 4. What is the range of the function y is equal to 5x when the domain is 3, 4, 5, 6? So this is our solution to this question is we're going to use or apply the concept of algebra. So in a sense that we'll be substituting. So the domain are the x values, right? So given this function, y is equal to 5x, uh, let's say y is equal to 5x, but then let's try to use number 3 so to find its range counterpart. So 5x times 3, y is equal to 15. So first we have 3, 15. That's our first coordinate. Right, so I think you get the pattern. We just given the remaining 3 domain values, we find the y. So y is equal to 5 times 4, which is 20. y is equal to 5 times, say x is 5. Y is equal to 25. And say that y is 5 generally speaking, but then in specific, let's say x is 6. Y is equal to 30. So with all these, know that the next coordinate would be for, what's this one? 20. And next is 5, which corresponds to 25. And let's say 6 correspond to 30. So this is the final answer. Let's just highlight the actual, what the question is actually looking for. I can't highlight them. But yeah, I think you get it. This is 15, 20, 25, 30. Those are the range elements. Now, for letter C, you have to determine whether each table represents a function, and we're supposed to explain. So, for number 1, let's see if there are any repeated values in the domain. There are none. So this is a function. So there is no element in the domain that is repeated. That's the reason. I won't be writing the reason anymore to make this video a little shorter. Alright, for number 2, non-function. This is a non-function. I already said the answer. Why? 2 elements in the domain are the same. So yeah, non-function. For number 3, for the domain, you have 1, 3, 5, 7. No elements are repeated, so this is a function. For number 4, 1, 2, 3, 4. This is a function. No x values are repeated. So yeah, that's everything for this video. I hope this video gives you quite at least some knowledge about the definition of functions. I won't be able to cover everything, as this is just an extended effort of me trying to record everything that's being taught in my school, to archive them so that later on in my life it would help me. I hope it will also help you in your own studies. If you've tried searching on YouTube about this particular lesson, I hope it had helped you. I hope it has helped you at least in a certain extent. Yeah, that's the end of this video. Thank you for watching.